Hello, welcome back for part 2 of solving compound inequalities. This one we're going to focus on the word or. The graph of a compound inequality involving the word or is the union or the combined region of simple inequality graphs. And when we take a look at our first example here, we have in words all real numbers less than 2 or greater than 6. And in algebra, we show that as x is less than 2 or x is greater than 6. When we graph those, because neither one of these are equal to, we're working with open dots. So for x is less than 2, we'll have an open circle here. And then if x is less than 2, it's all the numbers, all real numbers, to the left. When x is greater than 6, again, it's open. So if we find 6, we put an open circle. And because x is greater than 6, it's all real numbers to the right of 6. And you'll notice that there's this gap here. That means that the answers 3, 4, 5, or any other real numbers in this position will not be solutions of the original problem. The second one we have is all real numbers less than or equal to 2 or greater than or equal to 6. Same thing, except this time it says they're or equal, which means they are a closed circle. And so if x is less than or equal to 2, it could be 2, or it could be all real numbers less than 2. X is greater than or equal to 6. It's a closed circle, and all real numbers that are greater than 6. These are the solutions, so this time it includes 2 and 6 to this issue. So let's go ahead and practice. So we're going to solve each compound inequality, and then once we're done, we're going to graph them. So I have negative 4 plus x is greater than 1, or negative 4 plus x is less than negative 3. And in cases like this, it has to be done separately, whereas when we use the word and, we could do all of the work at one time. These have to be done separately. So we have negative 4 plus x is greater than 1. I want x by itself, so I'm going to add 4 to each side to move that 4 over. So that's 0. X is by itself. Go ahead and bring down my inequality symbol. And 1 plus 4 is 5. So we know that x is greater than 5. Then we have negative 4 plus x is less than negative 3. Again, we're solving for x, so we're going to add 4 to each side. X is by itself. Bring down my less than symbol. And negative 3 plus 4 is 1. So then that's where we get our x is less than 1. So because x is greater than 5, it's an open circle. Oops, it's red. Keep them color-coded here. And then all real numbers that are larger than 5. When x is less than 1, it's less than, so it's open circle, and all numbers to the left of 1. And if we graph the union, if we graph both of them, we see that we have our open circle, and to the right starting at 5, and we have an open circle starting at 1 and going left. On example B, we have 2x is less than or equal to 6. Oops. Forgot my x. Is less than 6. And then we also have 3x is greater than 12. Okay. In both cases, these are multiplications, so I'm going to divide both sides by 2. It moved to positive, so this does not change. 6 divided by 2 is 3. And then over here we are dividing by 3. X is by itself. Moved to positive, so the symbol does not change. 12 divided by 3 is 4. And now we're going to graph these two solutions. So we have x is greater than or less than or equal to 3. So less than or equal to 3, there's 3. It's closed because it says or equal to, and it's all numbers to the left. Then we have x is greater than 4. So it's greater than 4, so we find 4. It's an open circle, and it's all numbers larger than 4, so off to the right. If I were to graph the union, it would be a closed circle, left, open circle at 4, and to the right. So this is saying that the only numbers that will not work are numbers greater than 3, but less than 4. Okay? Okay, there we have these two. I want you to go ahead and practice those. If you have any questions, please come see me.